All right, so the 402, I put in here this factoring flow chart. We're going to refer back to this a different day. But to start with, we're going to start learning just, hey, what is the zero product property? Because remember, factoring is a way to solve a quadratic equation. And so we need to find out what the zero product property is to help us solve a quadratic equation. Remember, solving a quadratic equation means finding the x-intercepts on a graph. But there's no graphs drawn on any of these examples. We're learning how to solve them algebraically. So you are going to learn how to go from standard into factored form this unit. But right now I'm giving you the factored form. And so the zero product property, you already know from math. Basically, if you're multiplying two numbers and the answer is 0, then one of the numbers had to be 0. So down here, if you're multiplying two factors and the answer is 0, either the first factor had to equal 0 or the second factor had to equal 0. What value for x would make the first factor equal 0? 3, because 3 minus 3 is 0. And in the second one, 6, because 6 minus 6 is also 0. So your two solutions are 3 or 6. Now, a lot of students refer to this as, oh, it's just the opposite of what's inside the factor. Yes, that's true. I think of it as what number do I plug in for x so that x minus 3 gives me 0? And the answer would be 3. So the same thing in this one. What value would you have to plug in for x to make this factor 0? You would have to plug in -2. And you would have to plug in -1. So -2 and -1 are the solutions. This one's a little bit tricky. So this one just has a factor of x in front of the parentheses. So what would x have to be? X by itself would just have to be 0. And x in this factor would have to be 5. Now, if you actually looked at the graph of the quadratic function, so for example, I'm going to graph this one, x times x minus 5. I just want to show you that guess what? The x-intercepts are 0 and 5, just like I predicted from my factors here. So I'd like you to pause the video and take a minute and try 4 through 8, solving for where the factors are 0. So pause now before I go through and do the examples. All right, now we're going to answer these questions. This could be written as x minus 10, x minus 10, but I don't want you to write out anything or multiply anything. X would have to be 10. So this only has one solution, just like when we graphed on this page and we only hit the x-axis in one point, there might be some situations where you only have one x-intercept. All right, you should have gotten that x could be -4 or +3. X could be 0 or -4. X, okay, this is a tricky one. So if you look at all of the preceding examples, we had a linear x plus 4. Now we've got 3x plus 2, which you might not be able to do in your head. So you're going to write down your two equations and set them both equal to 0. So 3x plus 2 equals 0. Then you're going to subtract 2 to the other side of the equation to get 3x by itself. And your last step would be to divide by 3. So x is either -2/3, add 1, so 4x equals 1, divide by 4, x equals 1/4. So if you didn't understand that strategy, then take a minute and try example 8 by yourself before I write the answers. Do I need to threaten you again with Buddy the Elf? Do it yourself, do it yourself. All right, so where is 4x minus 2 equals 0? And where will 2x plus 4 equal 0? So you're writing two different equations from those two factors. And there's no x out front, so that 2 could never be 0. So I'm just ignoring that. All right, so 4x equals 2, divide by 4, and x would equal 1/2. Subtract 4, 2x equals -4, divide by 2, x equals -2. So you just learned the zero product property. That is great when it's already in factored form. It gets you the x-intercepts or the solutions on the graph. So now we're going to learn a couple strategies of how to actually get standard form or other forms to look like they are factored. So the first strategy is called the greatest common factor. And here are your steps in case you forget how to do this, but you're going to find the greatest common factor of the coefficients. Then you're going to find the greatest common factor of the variables. You're going to write your greatest common factor outside parentheses, divide the original function by the GCF, and write the quotient in the parentheses. Let me show you what that means. What is the greatest common factor of 2, 4, and 6? It is 2, right? So I'm going to write 2 outside my parentheses. Then I'm going to go divide the entire equation by 2. So 2x squared divided by 2 is x squared. -4x divided by 2 is -2x. And 6 divided by 2 is 3. So my answer is 2x squared minus 2x plus 3. Okay, what could I divide both terms by in this equation? I could take out a 9. If I divide by 9 on both sides, I would have x squared minus 9. So I divided out a 9, and then I wrote what was left. If you distribute, 9 times x squared should give you back your 9x squared. 9 times -9 should give you back your -81. What could I divide number 3 by? I can actually divide out a 2, but I can divide out an x as well. So if you can divide out a variable, you also want to divide out a variable. So what is 6x squared divided by 2x? 3x. And what is 40x divided by 2x? 20. So 2x times 3x plus 20 would be the solution. So you might want to take a minute and pause and try 4, 5, and 6 if you're starting to understand the greatest common factor, or you can do it along with me if you don't want to pause. I can take out a 3, divide out a 3 from each term. When I divide by 3, what will I have left? I'll have x squared plus 2x plus 3 left. Notice I couldn't take an x out that time because I didn't have an x as part of this term. All right, example 5, I can divide a 5 out. So if I divide out a 5, divide by 5, I'll have x squared, right? Oh, sorry, 10x squared divided by 5 is 2x squared left. 20x divided by 5 is 4x, and 5 divided by 5 is 1. All right, I think you should try to take 6. Take your own shot at 6. What can I divide out? They both have an x term, and they both have a factor of 9. So I'm going to take out a 9x from both of these terms. I will have x minus 2 left. So 9x times x minus 2. Okay, so I want you to look at the difference between examples like 1 and 4 and example 7. Up here, it just told me to factor. Down here, it's telling me to solve. You see how these are all equal to 0? They're looking for an answer in the end. So what you need to do is get it set up by factoring and then actually do the zero product property and come up with your x equals solutions on these. All right, what's my greatest common factor? I can factor out an x. So x times, now what is x squared divided by x? X. and 5x divided by x is 5. If that is equal to 0, now I need to come up with my two solutions. X is 0 or negative 5 are my two solutions. So we had to do the factoring step and the solving step all in one equation. All right, let's try example 8. What can you pull out as a greatest common factor? You could pull out a 6x from each term. So I'm going to divide by 6x. Now I have x minus 1 left because 6 divided by 6 is 1. All right, so what would x have to be to make this equal 0? X is either 0 or positive 1. Are you beginning to see how the zero product property works? It helps you find solutions when you're in factored form. Okay, this last one. I want you to think for a minute. What can I divide out of 4x squared and 40x? So I can divide out a 4x, x plus 10. So I've got 0 or negative 10. X equals 0 and negative 10. That's the greatest common factor strategy. So if you look at your factoring flowchart, what does it say at the very top? Don't forget to pull out the greatest common factor first. So no matter what you're doing, do you see that step 1 is always to look for a greatest common factor? It is going to make your life so much easier if you look for the greatest common factor first. Now, there are several different strategies. We're going to look at difference of squares today, but we're also going to look at when there's a trinomial or grouping, different methods. So our last strategy for today is to look at the difference of squares. Okay, so the degree has to be 2. It has to be a quadratic. It has to have 2 terms, and they both have to be perfect squares. We might want to review what perfect squares are. What's 1 squared? 1 times 1 is 1, right? What's 2 squared? 2 times 2 is 4. 3 times 3 is 9. Why don't you take a minute and try to fill this chart all the way down, and I'm going to fill it in and then just show you the answers. So pause. Okay, I filled in all my perfect squares, and you should have too, because it's great practice and a link from geometry when we dealt with perfect squares. The only one I had trouble on was, I forgot what 14 squared was, but then when I checked, I remembered 13 is 169 and 14 is 196, kind of a cool rule that they flip-flop. And then I skipped all the way up to 20 squared because I don't know 16 or 17 squared myself, so I'm not going to expect you to recognize those. But these are perfect squares from Pythagorean theorem and geometry that you should recognize. All right, so here are the examples. If you are taking x squared minus 9, you are allowed to make 2 different parentheses. You're going to put the square root of the first term, so the square root of x squared is x, and you're allowed to take the square root of the last term. The square root of the last term is 3. You make 1 parenthesis positive and 1 parenthesis negative. This is called difference of 2 squares, and the trick is when you end up doing FOIL or the box method, see how x times x will give you back x squared, and 3 times negative 3 will give you back the negative 9 if you were going to multiply this out. What does your outer and your inner term give you? See how it gives you opposites, negative 3x and positive 3x? That adds up to 0x. See how there's 0x? I could write this x squared plus 0x minus 9 if I wanted to. And that will happen every time. So you're always going to have opposite signs here so that when you add your outer plus your inner term, you get 0. So you're going to set up your 2 parentheses. You should always look first to see if you have a greatest common factor, which this doesn't. And then you're going to take the square root of each term. Square root of 81x squared, 9x times 9x. Square root of 25, 5 times 5. 1 gets a plus, 1 gets a minus. So you are going to do that on all of these examples, but I want you to look out for 2 things. I want you to look out for a plus sign, because whenever you have a plus sign of two squares, it's considered prime. It's not factorable. What do you think this would factor into? Probably like x plus 10 times x plus 10. What happens when I multiply that out? X times x is x squared. I get 10x plus 10x is 20x, and 10 times 10 is 100. Do you see how that does not give you back x squared plus 100? The sum of squares is prime. You can also not do difference of squares if you don't have a perfect square. 2 is not a perfect square. So I can't take the square root of 2, right? So this is also a prime example. So try pausing this one and see if you can do your binomials on each of these. These are both going to start with x, right? Because square root of x squared is x, square root of x squared is x. So this one would have to be x plus 7, x minus 7, because 7 times 7 is 49. X plus 2, x minus 2, because 2 times 2 is 4. Now I've got a bigger number in front of x squared, so I also have to take the square root of that number. 10x times 10x, and then I would have plus 1 and minus 1, because the square root of 1 is 1. The last one would be 3x plus 8 and 3x minus 8, because 3 times 3 would give me 9, 8 times 8 would give me 64. Do you see how all of these different factors look like it's the same pattern every time? You're taking the square root of each term and then writing one with a plus and one with a minus. So now try pausing and see if you can factor 7 and 8 at the bottom and come up with your answer using the zero product property. So now I'm going to factor them. This should have factored into x plus 8, x minus 8, and then I want to know what x has to be. X has to be negative 8 or positive 8. And this one should have factored into 2x plus 5 and 2x minus 5, which is a little bit harder. So 2x plus 5 equals 0, 2x minus 5 equals 0. Subtract 5, 2x equals negative 5. X equals negative 2.5, right? If I take negative 5 and divide by 2, I get negative 2.5. Guess what? This one comes out to positive 2.5. And if you look at the pattern, you're going to move this term to the other side and then divide by this term. So 5 over 2, oh sorry, negative 5 over 2, positive 5 over 2 give me my solutions. All right, so this is the guided practice that I'd like you to try from page 402, and we can go over the questions that you have that you don't understand, but the guided practice on 402 can now be completed.